Okay, probably we want to start now. It is 11:01. Hi everyone, thank you for joining us for the presentation of post-harvest pathology committee meeting. In our today's meeting, we will have two speakers. It is my great honor to introduce our first speaker, Dr. Gianfranco Romanazzi. Dr. Romanazzi is a professor of plant pathology at Marche Polytechnic University in Ancona, Italy, working on sustainable approaches for the management of post-harvest decay of fresh fruit. Since over 20 years, his team investigates the effectiveness and the physiological changes in the host by application of chitosan or natural biopolymer obtained by crab cells. Currently, he is a president of Italian Association for Plant Protection. The title of Dr. Romanazzi's talk today will be use of chitosan and other basic substances for the management of post-harvest disease of fresh fruit and vegetables. At the end of the presentation, there will be about 10 minutes for questions and answers. Please hold until then. Please use the Q&A icon in the Zoom if you have any question for the speaker. Following Dr. Ramanazzi's presentation, Professor Samir Drobi, Chair of International Society for Plant Pathology, Post-Harvest Pathology Committee, will briefly talk some of their activities. Now the podium is yours, Dr. Romanazzi. Take it away.
Yes, I am, and thanks for the committee for inviting me to deliver this talk. I wonder just if Samir Drobi wants to anticipate her welcome in case he's busy with other activities.
No, go ahead, Gianfranco, and I'll talk after you finish.
Okay, thank you, Samir. Thanks to you all. Thanks to IPS Post-Harvest Pathology Committee, and thanks to ISPT Post-Harvest Pathology Committee. It is a pleasure to share with you some of our recent investigations. Subject of the talk will be dealing with, we have some experience with this biopolymer called chitosan and other basic substances. And I hope you can hear well. What are those basic substances? Are compounds that are natural and we use in the diet, and we can apply on the plants. We know that we need to be sustainable, so we have the SDG that we need to follow to leave a better world to the future generations. And in Europe, this strategy is applied with the so-called farm to fork. So it moves from the grower to the consumer, and it plans an increase of organic agriculture, a reduction of the food waste, and just one pathogen. Here it is a review that we did some years ago with Samir, where we surveyed all the infection by botrytis on a list of crops, and it is also planned a halving of the use of synthetic pesticides. And this is not easy to achieve, but it is something that the consumers want, and we need to go forward. We know that a big amount of what we produce is lost, more or less half of fruit and vegs, that contains a high amount of water. Where the amount of water is lower, we have a reduced amount, but it is not lower than 20%. And if we go in a packing house, we can see some threshed fruit, but this happens also at home, and more than half of those waste happens at home. Consider a lot what it starts on the field and reach the retailers, and so the consumer is not involved in, and waste what it moves from the retailer to home. And statistics in Europe tell that we waste more than 170 kilo per person. So it is a huge amount. And we met recently in Cesena within a project called Stop Med Waste. And Gianni Ceredi, a friend of us, took us a bunch of fruit with a lot of symptoms. Those are all fruits that cannot, or vex, you can see aubergine and so on, that cannot be eaten, so are lost and are lost forever. And they infect other fruit, they contaminate all the box. So this contributes a lot with the waste. And also we have to achieve this target of reduction of waste with less pesticide. Because, there is a new regulation, European consumer, but I think not only European, I think the worldwide consumer is worried about the application of synthetic pesticides. People think that, normal people that has nothing to deal with agriculture think that we have to take away all synthetic pesticides because they are dangerous, or they have to ban all of them. And all the people produce comments, and they try to meet these requirements from consumers. And so there is a way how to reduce these amounts. So they took in consideration 3 years, and according to the average of those 3 years, within 2030, we have to reduce by half. It is not easy, and the country that use more have to reduce more than others. So, for example, in Italy, we have a lot of tree crops, so we use a high amount of synthetic pesticide, and we have to reduce. We are on the top of the list. We have to reduce not 50, but 62%. That is pretty high. While other countries are in the lower part because they use less, or they declare the less use, so they have a low reduction. We have also to take away the more hazardous pesticide, and here there is another list, and the different countries have a different position with this list. So this induces some worry from the growers, because it is not easy to have the same target of production with less pesticide. So there is a committee from the European Parliament that complained about this. And we also, as scientific society, asked to see crop by crop, or to give a study before to tell that we will cut by half, because it is not easy to do it by one day to the other. We need to make easier the registration of biocontrol agents. And here we have Samir, that is a researcher, but also Antonio and all other people that are involved, that have a good expertise with the registration of biocontrol agents, and they know how much difficult it is. So we have to take in mind, and we have to promote the registration of those compounds. And also the Commission told that you are right. We are already reducing this index. For example, there is the 14% reduction within the first years of the first indicator and 26 of the second. So the target can be reached. Also, there are the retailers that require an amount of synthetic pesticide that is lower than MLR. So it's not enough, the rule, but they want to go below the rule. And you know that a small amount of synthetic pesticide that is on the crop, it protects from post-harvest decay. So if they require a lower amount of MLR or a reduced number of synthetic pesticide residues, this can be a problem and can increase the waste and not decrease. A way to avoid the use of synthetic pesticide is to increase the resistance of the host. And we know that there are several mechanisms. There is the SAR and the ISR. ISR is usually targeted at the roots, while the SAR can be targeted on the canopy, so also on the fruit. And usually for post-harvest disease, SAR is a little more important than ISR. And it is important the priming, so a kind of alert of the host, so we can prime the host tissues with a kind of elicitation, and those host tissues react promptly to the attack of the pathogen as compared to the sensitive or unprimed hosts. And there are several mechanisms involved into this kind of molecular mechanisms that have been highlighted in this kind of elicitation. There is a specific review on priming of a few years ago that is very, very important from some colleagues that are very good experience in the field, Juv Conrad and other colleagues. So if somebody wants to know more, can consult this reference. So we have to go towards something that is less dangerous for the human. Then in the US, there is these categories that are called GRAS, generally recognized as safe compounds. There is a quite long list. You can see more than 1,000 compounds are into this list, but some of them are duplicated. But the list is very, very rich. And you can Google, you can log in and find all the compounds. We can translate this at the European level. We have the so-called basic substance. Those basic substances were approved with a regulation on synthetic pesticide a few years ago. And this regulation tells that if we have something that we can eat, because you know that for registration of synthetic pesticide is very costly, because we have to demonstrate that they are not dangerous for humans or animals or other organisms involved. So if there is something that we can eat, we don't have to demonstrate that it is not dangerous. So those compounds does not have a MLR, they usually does not have pre-harvest interval, they are labeled with the name of active ingredient, and they are usually approved in organic farming. It was a call toward the application of those basic substances, and we answered this call with a project. Also, Antonio, Simona, and a list of other colleagues are involved in this project. There is a post-harvest community, and some of them are involved in this project called the Eufresco Basics. We had a list of webinars, we had some resources studying these basic substances. Some of those basic substances are already used in agriculture. For example, the vinegar, we use the vinegar to store our food. So since it has antimicrobial activity, but vinegar is important, for example, for disinfection of the tools. So we can use them in organic agriculture. Sodium bicarbonate, we will see later some data obtained from Antonio's team, the chitosan, the nettle extract. It is used, for example, for pest, but also for pathogen. So this regulation turns in practice what in organic agriculture we used since time. So we have a list of 24 compounds that are approved, but we have also the resources of compounds that are not approved, or the ones that are under evaluation. For example, the ozone, a compound is under evaluation. The water is a compound that is under evaluation. The caffeine and so on, sodium hypochlorite. Sodium hypochlorite can be next one, can be the 25th basic substance that can be approved. I just asked if it is so safe, and they told me that if you drink just a little bit, it's not dangerous. But you can see others did not pass the evaluation and were not approved. So there is a dossier that is evaluated by EFSA, and just a list of those basic substances. You can see the ones that are in red can be applied officially on strawberries. So we can have, those are the 24 that are approved. So Equisephum extract, chitosan hydrochloride, vinegar, urtica. Vinegar, for example, is used also as herbicide. Herbicide, at least in Europe, chemical compounds cannot be used as herbicide. But in IPM, you can use a vinegar or herbicide. Urtica, for example, for pests, a beer for some animals that can be into the field, sodium hydrogen carbonate, so sodium bicarbonate, hydrogen peroxide for decontamination of tools, lecithins, chitosan, but also the ion with asterisk, for example, so can be used in grapevine. So more than half can be used in grapevine. And here I was just the one that we know more. This chitosan is obtained by crab shell, and it is obtained from chitin. It is deacetylated, and it has multiple properties, so antimicrobial, film forming, and eliciting. And I remember that in one of previous meetings we met with Samir, and he told me, but we cannot use fish in all the diets. Now they approved compounds made by aspergillus, so obtained with fungi, and it is a commercial compound that is available on the market. So we have a number of formulations that are available. Although if we see the grass table, we have a list of compounds. For example, chitosan into the list here we have 6 of different origin, of different timing. For example, last one has a mixture of chitosan with beta-1,3 glucans from white button mushrooms, so for fungi as well. But we have the chitinase enzyme from aspergillus or shrimp-derived chitosan, chitosan from aspergillus, and so on. So whatever is approved in US is approved on this other side. And the first trials were done in Canada, in the team of Helena Celine. So they started by America, and they moved on this side. And where it was Ahmed Gaut, he was there, and he moved. I guess he's familiar to Samir and to Antonio because he worked at the USDA, and they had a very good research, very good investigation in which they set up this kind of protocol. They applied on several crops. It produced a film. You can see the film that is produced on the apple, but they applied on several kinds of fruit. And it was advised from Antonio to start with such kind of investigations, and it was worth. We started with the chitosan from Sigma. We dissolved in acetic acid, and when we did the fruit, we had this kind of film. So there is this film forming properties. We applied on table grapes. This is one of the technicians that is now retired, working at the University of Bari, and sprayed onto grapes. It produces this film that is, it takes for a while. Here it is a couple of weeks after the application. So in recent review, we can just show that this produces this coating on the fruit with a list of heterogeneous gas exchange. So it takes better, a little bit better the fruit. It induces the host resistance, and it has antimicrobial activity. So there is an extended shelf life and reduction of the waste. And this is a for sure incomplete list of compounds that are onto the market. We have them in different formulation. We have them in powder, usually with higher concentration. We have them liquid. We have them in paste, and so on. Usually the one that works better are the one with higher concentration, but we have a high biodiversity. And some of them, I guess, are also in the US market. We include some of them also from the US market. First trials were done on table grapes, and we saw that in post-harvest trials there is a depending on concentration, so higher concentration works better, while in the field, different concentration can have similar effectiveness. So the best target, at least for the first investigation, was gray mold. But Antonio worked with in this project, applying chitosan, but also applying sodium bicarbonate, and he can interview in the providing more details on those trials into the discussion, and they applied on different pathogen on sweet cherry with Anna Maria Mincuzzi and other colleagues. In the US, we worked with Joe Smalix some years ago, and we dissolved chitosan in a list of acids. The one in blue were the one that worked better, and the acid that was used for dissolution affected the thickness and the viscosity. So if we use hydrochloric acid, for example, we have a lower viscosity as compared to if we use acetic acid. And we applied on grapes, and we had a good management of, for example, downy mildew, and it was a surprise for us because it was not common, the application on grapes, and the growers started to apply it in the field, and they were happy of this kind of use. And we saw that although it is on the market as a resistance inducers, it has a strong antimicrobial activity. Here we see 4 decay-causing fungi. Those trials were done by Erika Pelliziani, our former postdoc. And if we see the fungicide, phenoxamide, chitosan, for some pathogens was pretty similar to synthetic pesticide. So there is a strong antimicrobial activity, but also benzotiadiazole that is on the market as resistance inducers has a significant antimicrobial activity. As well, nettle extract that is reduce the growth of different fungi. So most of those compounds and most of those basic substances induce resistance into the host, but as well reduce the growth of decay-causing fungi. And then we are involved with Antonio and other colleagues in a project called Prima. So there is this Prima Foundation that takes together different shore of Europe with surrounding countries, and we have a list of meetings, and next one will be in Tunisia with Professor Allagui. And Anna Maria Mincuzzi will be there as a speaker together with Luis Palou and others. And the idea of this project is try to tackle the waste, trying to reduce them, and reduce at the same set up strategies to reduce the application of synthetic pesticides, or provide to the market some impossible improvement. And then moving from the grower to the consumer. Example 2 of the compounds that can be alternative to synthetic pesticide are essential oils and chitosan, as well as we heard. And we use them alone and together, and we can see that together works better than alone, and they increase some of defense-related enzymes. So there is effectively induction of resistance. So this induced resistance, let's go toward the end of presentation, are getting popular. So if you see the score, they are becoming popular. And we can imagine a fruit that is in the middle of a battle where there is the pathogen that wants to infect, but we can trigger the defense with a list of tools. So we have hypobaric, hyperbaric, biocontrol agents, ozone, natural compounds, BTH, UVC, and so on. So this fruit has a list of tools that helps to resist toward the pathogen, but also the pathogen has the tools that can attack the fruit, a list of enzymes, toxins, cell wall degrading enzymes. So there is this balance, this equilibrium that can go toward the resistance or can go toward the infection, and this affected by environmental conditions. So we can try to increase the defense of the plant at different stage in pre-harvest or post-harvest, but there is a natural resistance of the fruit that is declining over time. So earlier we try to increase the resistance, and better it is. And we have to take in mind that there are some favorable sides of this intrinsic resistance, but also some room for improvement, because not all time is reproducible. The fruit can react or not to the induction of resistance, and the control is not the same of synthetic pesticides. So we can improve, of course, our tools, our protocols, but we cannot have any time the same results. It's not easy to turn into the packing house lines, and also the methods for intrinsic resistance are not standardized. But on the other side, we can have a long protection, we can have multiple target. They do not target the pathogen, so we can reduce the likelihood to have resistant isolates. As well, we have several compounds on the market that are becoming popular. There are no so many side effects. They lead to reduction of pesticide, and since the elicitation takes the increase of phenolic compounds, we can have some beneficial compounds into the fruit, and those fruit are healthier also for the consumer. So we have this kind of hurdle concept. This is taken from Antonio, where we can reduce with a list of hurdles the amount of disease, and even if we move from the highest disease level, we can reduce with a list of hurdles that are not complete, but reduce the amount of disease to an amount that is what the market require as threshold. So around 0.5 is the amount that is accepted, and applying different tools at the same time, we can have additive or synergistic effect that earlier or later can prevent the progress of the pathogen. And so we can have some compounds that can complement, or in some cases can also replace the application of synthetic pesticide. For example, in organic agriculture, we cannot use synthetic pesticide. Then this can be useful, can be good, and they can go to a fruit that is healthier and with a reduced amount of pesticide residues. That's it, and we will meet in Lyon with some of the people that are hearing into the talk here, and we will have a round table on the first day. And I thank Samir and David Espadaro that asked us to have a round table that we will share with Pervin Kiney on the first day of the meeting, and soon after the meeting in Lyon, the day after, we will have a meeting in Paris that we will close this project on basis stance. So in case you are around, you are welcome to join. And that's it. The next adventure that is just starting is cost action that is just approved, and it can be a new adventure in which we can be involved. And that is my side. Thanks you all for the attention.
Thank you, Gianfranco. It's a very, very thoughtful and a very great presentation. Yeah, if anybody has any questions or comments or suggestions, please, this is the time to sign in. You can unmute your speaker and you can speak. Or as I mentioned before, you can write your question in the Q&A box as well.
Hi, this is Gui Xiaohao from USDA and ARS at Curio. It's a very nice presentation. I'm wondering, you use chitosan, also some other polysaccharide. Did you use? I saw one picture use a laminarin. Is that right?
Which can you repeat me? Which is the polysaccharide?
Yeah. How that one effective compared with chitosan or laminarin? Did you ever combine them together?
I didn't catch.
Oh, you didn't hear what I'm saying. So I think you use some polysaccharide like laminarin.
Laminarin, yeah. Okay.
Yeah, you use the laminarin. I saw in one slide. So on that slide, laminarin treated looks like worse. It's worse than chitosan.
In that system, we tried to place together a list of alternatives to synthetic pesticide, and the laminarin, since we have several compounds available on the market based on laminarins, actually we have two ones. One is registered as plant protection products, and another is registered as biostimulants. The one that we used was not registered as plant protection products because it was not yet on the market. These plant protection products came later. So in that system, it worked a little bit less. Then we placed it together, we combined this laminarin, so it was effective. But the effectiveness was not as strong as the one of chitosan. There is a formulation that takes together laminarin plus yeast extract, because the yeast extract are sold by the plant are something that looks like a fungus, so they activate the defense. So it was a significant effect, but I guess that laminarin has a good eliciting activity, but not as strong antimicrobial activity. Then we need a good antimicrobial activity to have the double or the triple effect if there is the coating activity as well.
Okay, yeah, thank you. Another question you have a lot of passages. I didn't notice which one. So do you think when is the treatment effective for the we know for the pathogen, some is biotrophy and some necrotrophy. Did you notice any difference with different, it's better for biotrophy, more effective for treatment, or for the necrotrophy? Or the applied time may be important for all this? You have some comments on that?
Actually, I don't have an overall answer, but I can tell you that it's better to try system by system. For example, on necrotrophic pathogen, as Botrytis cinerea, we tried chitosan, but we tried also a list of other compounds, and they work. For example, lactoserum. You can imagine that it works all the way. It works. It has some effectiveness. Nettle extract and so on. So usually post-harvest decay are necrotrophic. But we tried also on biotrophic, for example, the downy mildew or the powdery mildew, and they were effective as well. Then you have to try and to test at the beginning with different compounds, different concentration, different timing of application, because timing of application is a very sensitive issue, and you have to try to do your best to get a complex experiments, maybe starting from small scale, going to large one, to go toward a protocol that can have a significant effectiveness and can be comparable to the standard, or if you are lucky, even better than the standard, or similar to the standard with some benefit. For example, we apply toward downy mildew, and we can replace the copper. Copper accumulates into the soil, so if we reduce the amount of copper, this is a beneficial effect, or even with the same level of protection.
Okay, yeah, thank you very much.
I see Ochala is raising hand.
Hey, Gianfranco, very good presentation. Thank you for putting all this together. So I had some question regarding the chitosan. So I was wondering mostly about your HODL concept. That sounds really promising. So was it more towards the pre-harvest application side, like orchards or vineyard aspect, or was it more towards the post-harvest? So what was the timing of application on that?
Oh, thanks for the question. This is a sensitive issue, and it is not easy to have as well an overall answer. It depends on the fruit, for example. If you have strawberries, you cannot dip the strawberries in a solution after harvest. As well for grapes, you cannot dip the grapes. So it will be nice to have a pre-harvest application. And then it is important the timing of pre-harvest application. So when I had some more years and I was a postdoc, I went into the field targeting, and Antonio obliged me to do it, to target the flowers of strawberries, the small fruit, and the white fruit. And it worked better on flowers and on white fruit, because you know that gray mold, Botrytis cinerea, infect at the flowering stage, and then it remains latent until harvest, then it develops after harvest. So wherever it is possible to have a pre-harvest application, it is easier. You can apply the chitosan post-harvest on the fruit that are deepened in the solution. For example, you can do with apple, you can do with peach, but the pre-harvest application try to remove the latent infection, something that post-harvest application cannot do. Can slow down, but it cannot act toward the latent infection. So management of latent infections comes to pre-harvest application. If there is a chance to apply even post-harvest, you have to take care to dry very well the fruit, because if the fruit remains wet, you cannot have good results.
Okay. Yeah, thank you. And following up on that, so how commercially viable is this? Are there products already developed, or is it still in the experimental scale?
At least in Italy, we have dozens of products available on the market, and growers are competing each other to have a better protection and a reduced amount of residues, because you saw that the retailers are increasingly strict in the amount and in the number of residues. So even replacing 1, 2, 3 treatments with synthetic pesticide or with other tools, you can reduce the risk of resistant strain, and you can reduce the risk to find the residues on the fruit. So we don't have general rules, but you have to try, and there is a pretty high number of products on the market. You have to take care of the ones that are too diluted, because if you don't give the product, you may not have a result. So you should provide a significant amount of the product onto the canopy, whichever it is.
Okay. Yeah, it's interesting to see all those data, because I think chitosan has been researched for a long time, but not seeing its popularity in the post-harvest world. I'm just, like wondering what's its efficacy and what are the challenges behind that. So yeah, it makes sense. Okay. Thank you.
Thanks to you as well.
Thank you, Atala. Anybody has any more questions? I have the quick question, Gianfranco. For the chitosan, do we know, does it have any effect for the any improvement in the cell wall thickness, or like any physical barrier, so that the either for the mechanism standpoint, how much information do we know what the chitosan is really doing in the plant?
Yeah, we have some, I didn't include the presentation, some changes in the host. For example, on strawberries, we had an elicitation in the host tissues. We applied just soon after harvest, at different timing before harvest, so 0, 6, 24, and 48 hours. Chitosan and the BTH, benzothiodiazole, that is Bion in Europe, and I guess Actigard in the States. And they both protected the fruit. but they both elicited different pathways. And the pathways elicited by chitosan is different than the one elicited by BTH. Both provided an increased PL1, so SAR, but chitosan induce a film onto the fruit. So there is an effect on the photosynthesis. That was a surprise for us, because you can tell the fruit photosynthesis in the fruit, so because there is this barrier, there is a reduction of gas exchange, and there is a reduction of enzymes that are linked to photosynthesis. So basically, there is a list of physiological changes into the fruit that are inducing follow the application of this. But this is just, we use it as example. There is a list of inducers that can be used and can be hopefully profitably produce a reduction of disease.
Yeah, that's thank you so much. Yeah, I am familiar with the one study. They used the chitosan in a soil, and they found the chitosan also kind of improved to increase the population of beneficial microbiomes in the soil as well. Yeah, it's good to see the kind of multiple effects in the different system. Anybody has any more questions or any thoughts?
Yeah, just a comment, just to follow up on what you just said, Shyam.
Yes, sure.
Actually, applying chitosan to the fruit surface or a plant or the mother, it might also, you indicated that it might change the microbiome, the whole assembly and the composition of the microorganisms. And this by itself can have a very significant effect on the control. Rather than having a direct effect of the chitosan, rather modulating the whole composition of the microbiome by increasing, for example, chitolytic microorganisms, different bacteria and yeasts, increasing their population and on the fruit, and this by itself can have a direct effect on the pathogen or the control. And I have no idea if anybody looked at this aspect, Gianfranco. This is really very interesting direction to go, and to see basically that maybe we are used to ask questions. Maybe that chitosan is not really having a direct effect, rather than having an indirect effect by modulating the microbiome. What do you think?
I can tell you that we did, but we do not have yet the results.
In the future.
I'm very curious to see what it comes out.
Yeah. I think you will get results. We have done something like that, and it's really affecting the microbiome very significantly.
Yeah. That's a really good thought. Thank you for sharing that information, Samir. Yeah, now let's conclude this year, and thank you so much again for Dr. Gianfranco Romanazzi for this nice presentation. And this is the time. Samir, can you briefly introduce yourself, maybe your research program, and some of the activities that your committee is doing?
Yes, just first let me compliment Gianfranco. He did a very good job as always by doing this comprehensive review of all the work that has been done on alternatives. It's really still a challenge, as Gianfranco just presented it. It's still a challenge to develop and reduce the waste and also the residues in the fruit. I'm quite sure there's still a lot of work to do. Really, this is really ongoing work, and to my understanding, and I believe that none of these alternatives as a standalone treatment by itself will really provide the level of control that fungicides are providing, but rather than having a combination treatment on the following the diagram of the hurdle the hurdle strategy, that it will require more than one treatment or one application of maybe different alternatives, different modes of action to achieve the level of control required by the industry, which is basically zero waste. So we still have a lot of work, and of course the young people among you will have a lot of work in the future. Maybe we will be out of this business within a few years from now, but the younger generation will continue for sure. So, and I'll just briefly, I don't really want to take too much time, just briefly introduce to you some of the activities. And I really appreciate this initiative, Shyam, that you are doing with the APS committee, post-harvest committee. And I really hope that APS and the ISPP post-harvest committee continue their collaboration in the future. It's
Thank you, Samir. Yeah, we look forward to do the collaboration. Yep.
Yeah, we did that collaboration in the last Congress, which was in Boston, the International Plant Pathology Society. It was really very fruitful collaboration, and I'm hoping that in the future some more webinars or some more meetings or collaboration will continue to be between the two committees, because after all, we all doing very similar or some really interesting research around the world, and it's very good to have a collaboration between all of us. So in the International Society of Plant Pathology, we have what we call it a subject matter committee, post-harvest pathology, which is I am chairing, and David Espadaro is the secretary of this committee. And we have been doing some activities in between the congresses. We usually held 2 international symposia on post-harvest pathology. We had one in 2019 in Belgium, in Liège, and last one was in Cyprus, in Limassol. And it really was very successful because it's dedicated to post-harvest pathology. We don't talk about anything else except post-harvest pathology. And it's kind of a working group meeting, because everybody knows everybody, and a lot of collaborations usually starts from this meeting. So this activity is under the International Society in the post-harvest pathology committee under the International Society of Plant Pathology. It's in collaboration with the International Society of Horticultural Sciences, ISHS, and it has been very, very successful with a very interesting and exciting. These activities are every 2 years, and the next one is going to be in conjunction with the International Post-Harvest Congress, which will be held in New Zealand. So it will be a joint meeting between them, and we will have like a concurrent session all 4 days on post-harvest pathology, and this will be a great opportunity to expose our activities to the more wider international post-harvest community. So this is the main activities, and I just want to point out that in the meeting in Lyon, the International Congress of Plant Pathology, we will have a really very nice program. We managed to get 2 concurrent sessions. One in the morning, and the first day on Monday. The first day of the Congress will be in Monday morning, and the other one will be in Monday afternoon. It will be the whole day, which will be dedicated for post-harvest pathology. And in the evening, we will have 2 evening sessions. I'm not sure if will be in the same day or one on Monday and the other one will be on Tuesday. And the sessions, let me just let you know what will be the sessions. Very, very interesting topics to be covered. Last time in Boston, we have like a huge crowd coming to our sessions, and it's really was very, very successful talks. So the first session will be on interaction of post-harvest pathogens with the host and its microbiome. There will be 3 talks, invited talks, and 3 contributed talks. You can go to the program, to the website of the Congress of the program, and you can see all the information about the invited speakers and the talks. And the next the afternoon session will be on sustainable management of post-harvest diseases and new technologies and approaches. This session is organized by Jim Adaskevich and Neos Toshido from Spain, and it will also include 3 invited speakers and 3 contributed talks, and all also will be in very innovative and new directions in control post-harvest diseases. In the evening session, we will have one session about really a new subject, which we have been trying to promote, which is called the pathobiome. The pathobiome, this is a new understanding of the post-harvest disease process. Just few words about it. I think it is exciting topic that now we are actually viewing, trying actually to understand the disease or the disease process, not only caused by a single pathogen, rather by other microorganisms also participating or facilitating or whatever we call it, enabling the pathogen to infect and develop a disease. And we have been looking on this subject, and this is one of my research subjects in recent years, trying to look how the other components with the microbiome or some other components of the microbiome facilitate the development of the disease by a pathogen. This is really very exciting. We have some new insights on this. This will be a roundtable evening session, and it will be also open for discussion, and maybe we can come up with a new thoughts and new directions for the future. And the other evening session will be headed and moderated by Jeff Franco. Jeff Franco, he will continue talking about food waste, and he will also host some people from the project that he has with the others on this in the Mediterranean area. So this is really it's going to be a very nice meeting. I encourage everybody of you to attend. You will of course learn a lot from the other sessions, and the general sessions is usually every 5 years. So it's a great opportunity to come and participate. So just few words about what I have been doing. As most of you maybe know, my focus is on biological control, and in recent years I have been trying to understand the microbiome and its relation to biocontrol and how we can modulate the microbiome, and studying all the dynamics and the assembly of different components of the microbiome on fruit before harvest and after harvest, and how this is affected by different treatments. Could be biological, could be chitosan, it could be anything, and how it affects the microbiome and how it results in decreasing post-harvest decay. Of course, there are some other projects. We can just leave it for another opportunity. Thank you very much, and thank you for the opportunity, Shyam, to introduce to you all our activities.
No, thank you so much. It's really helpful. I'm just curious how, for the logistic for the meeting, how often do you meet?
Well, to tell you the truth, do we have anybody from France in the audience? It was not easy to deal with the organizing committee in this meeting, and all our arrangements started, I think, 2.5 years or 3 years, even before the meeting. We started already negotiating with them the sessions and having some Zoom meetings and trying to really having our slot. The problem with this international big meetings is having the post-harvest pathology usually ignored, and it does not get the credit, doesn't get the slot that it deserved. So it was not easy, but at the end we managed to get one full day and 2 evening sessions, which is really very good. And it is in the first day. Usually they just push us to the last day, so but this is the first day, so everybody is fresh, and I'm quite sure it will be very successful too.
Yeah, sure. Thank you for sharing that. Then to become a member or to affiliate with your committee, then do we have to be a member of the International Society for Plant Pathology? Or, for example, let's say if I want a member in your committee, what's the process to become a member?
Yeah, there's no special requirements. There is no membership fees or whatever. Once you register, to the Congress or one of the Congresses, you will be an automatic member, and your name will be there. So there's no any special requirements for that. Once you are added to the mailing list, you will get all the information, and you will get all the activities and the newsletter and everything. So it's not like ISHS that you have to pay membership to be this, but it's open for all.
Oh, that's good to know.
Yeah.
Hi, Samir. I had a quick question regarding the ICPP. It seems like you have all the dates and the time for the post-harvest sessions. So how do we know? Because I'm trying to get to the ICPP website and trying to see if we have the designated time for those, but I could not find it.
Yeah. I think it is already on the program. I think they have posted it recently, but all the sessions are listed there. I'm not sure if they already allocated the time and exactly. But if you want, I can send you the program so you can have a look. Just drop me an email. I'll send it to you.
Okay, yes, please. Yeah, that'd be helpful.
Yeah,
and since this is the post-harvest committee interested in the post-harvest diseases, I just thought I would also share that. Yeah, there was a 3rd session on the post-harvest, and I'm sorry because I think it came late in the game, but we managed to get in there, and we hope that you would that session as well.
Yeah, sure. Yeah, I'm aware of that. It was not really organized by our committee. It came late, and I personally, as the chair of this committee, did not know about it. I know just after it was accepted. But yeah, it will be another post-harvest, but on different aspects, like more environmental type of ecological type of thing. It will be, I think, maybe on Wednesday. I'm not sure, but could be on Wednesday.
I see.
Yeah, it will,
thank you.
Yeah.
Okay, sounds good. It's already 1 hour. Let's thank one more time our speaker, Dr. Ramanaji and Dr. Drobi, and we will keep in touch.
Thank you. Thank you all.
Thank you.
And hope to see you in Lyon.
Yeah, it's good. Yeah, thank you. Bye-bye.
Bye-bye.
Thank you.
Bye.
Bye. Good evening.
Bye-bye.
Bye-bye.